Good day, Seahawks. Last part of Lesson 8. You got a little bit of a break from me with Hans Rosling there in video 8E. This is 8F. A couple last things to think about scatter plots and the relationship between two variables. Once we get into Lesson 9, we're going to start figuring out how to build that linear model, come up with a straight line that best describes the relationship from the data. Okay, so odds and ends here should be a relatively quick one. Two examples to start. For each of them, try to think what the scatter plot might look like. What's the direction, the form, the strength, unusual features. Think about which variable would be the response. Of course, that's y. Think which would be the explanatory. That would be x. And we'll come up with a possible scatter plot. Obviously, we're just making this up on the fly, so the scatter plot is not what would actually happen if we collected data, but it could happen. All right, number one, letter A, a sample of drivers. One variable will look at their blood alcohol content, and the other variable will be reaction time. So we got to think, what do we want to predict? And it's pretty obvious to me, but we'd like to predict your reaction time. You tell me blood alcohol content, BAC, and I'll predict your reaction time. So BAC goes down on the x-axis. Down here, we'll label it even as x, and we'll just abbreviate that as BAC, blood alcohol concentration. This is x. Clearly, this is the explanatory variable that leaves reaction time as the response up here on y. Right? And here's reaction time. Now, let's think of the units of measurements. If you're bone dry sober, your BAC will be at 0, and I sure hope most drivers on the road will be down here at 0. Legal limit in Maryland is 0.08%. So, well, we'll stick that here. Here's 0.8%. If I go halfway, the legal limit would be right in the middle, 0.4%. I guess if you're super drunk, up here, I guess that's right, 1.2%. Oh, I'm missing zeros here. I think you'd be dead. 0.08%. We caught that. 0.04%. I knew the 1.2 was the clue here. So, oh my goodness. 0.12%. All right, there it is, 0.08. Now, of course, you could be double the legal limit. Let's just hope in our sample of drivers nobody's off the board here and out of the video screen. Reaction time. Lots of times in stats towards the end of the course, we'll measure this on the internet. Typically, it's measured in milliseconds. So MS for milliseconds. And I have the scale here of results I've seen in class. So 100, 200, and 300. So we'll just put this at 0 as well, and then maybe we'll go up here to 100 milliseconds, maybe 200, 300. And these are data values that I've seen when we've run a test in class. Okay. Is it going to be linear? Probably. I don't know for sure. We've never collected this data, but I'm guessing what happens as you have more alcohol in your system. As you get drunker, what would happen to your reaction time? It would get slower. Slower is this way. This is a positive relationship, right? Slower. Up is slower. This is quick reaction times. And in fact, in my course notes from 5 years ago, I actually had this thing drawn this way because my mind was telling me, oh, slower must mean down, but this is a longer reaction time, which would be slower. Okay. Let's guess that it's linear. Could be something weird, exponential or something. I will just take a guess that it's linear. And let's we'll put a line here to sort of guide us, and maybe we get something that's looking like this. Okay. It will be positive. In terms of the dots, let's say we have 50 people or something, and we're going to run a test or just pick people randomly off the road. All the sober people here at BAC 0%, down in the corner, are they all going to have reaction times like right there? The answer is probably no. Here's a quick person, here's a slower person, here's an even slower person, even slower. Maybe this person is really slow. Here's somebody that's really quick. At this blood alcohol content, there's going to be lots of variation in reaction time. What happens as people start drinking? You're going to have lots of variation pretty much everywhere, right? So as I move to the right, more and more alcohol in somebody's blood. I'm going to make my dots real big here so the video can pick them up. All right. Who knows what this might look like? I don't know if we've gotten to 50 people yet. Could be something like this. Here's another one. There's somebody over here. I don't know, maybe you get somebody really drunk that's just pretty quick reaction time, even though they're pretty drunk. To me, the relationship would be pretty darn weak. So, probably weak, possibly something moderate. I just think that no matter what alcohol level you pick, reaction times are going to vary greatly. Once you get to the super drunk, off the video screen, off the board, then what's going to happen, I believe, is that reaction times will just skyrocket because people will just be completely inebriated. But if I had to guess, linear, positive, pretty weak relationship, and lots of variation at no matter what X value you pick, especially in this range, lots of variation. Would we say anything about outliers? Possibly not, because I think the relationship is pretty weak. It's really hard to talk about outliers when there's not much going on. Okay. Now you yourself at home, if you disagree with me, if you think there's going to be a slam dunk linear relationship, I could actually buy that. I've never collected this data. I think it'd be super interesting to see what's happening, but personally, at least me, you're going to get something like this. My thoughts. All right, so that's A. We'll go to B. I hope it's the same relationship so I don't have to erase this, but sample of Cecil College students, time spent on schoolwork versus GPA. I'll erase it. I'm feeling lazy on a Friday afternoon here, but we'll start from scratch. You'll have to catch up in your notes anyways, right? So. All right. Time spent on schoolwork versus GPA. I'm trying to predict your GPA. This is going to be the Y variable. 4.0, right? Let me make sure down here would be a 0.0. Here's a 1. Here's a 2. Highest you can get in college is a 4.0. So there's your Y. That's the response variable. We're going to use hours. To me as an instructor, this is probably the #1 best predictor to predict your GPA. College is a grind. Are you willing to put in the time, right? That's, if you go to class, that's hours. If you do your work, do your projects, study for your tests, that's all hours. Natural ability, once you get to college, might only take you so far. Well, down here would, of course, be 0 hours and only so many hours in a week. Maybe we'll do this weekly hours. Here's 10. Here's 20. Here's 30. 40. And possibly 50. So hours spent will be the X variable, explanatory. Here I think it's going to be positive, right? The trend would be the more hours you spend, the higher your GPA, so positive. Again, we never collected this data, but I'm guessing it's going to be linear. In terms of the strength, I think this will be a stronger relationship than that reaction time. So in terms of the strength, I would guess at least moderate, maybe something approaching strong. Problem is, it's not going to be super strong because there are a lot of factors that go into what a student's GPA. Natural ability, your inclination to do well on tests, just general intelligence level, how many hours you're working each week, are you caring for children, are you working full-time, etc., etc. This will be the number one, but it's not a slam dunk. You tell me your hours and I can perfectly predict your GPA. Probably lots of outliers here. Maybe the linear relationship might look something like, oh, I don't know. Maybe the line is, well, we're going to blast off into the 5.0 GPAs if I don't flatten this out, right? Maybe something like this. You have to spend some time, right? So we'll have some dots. Somebody could be here. Maybe one person's naturally gifted. Super high GPA, they don't spend a lot of time. There's a clunker down here. Maybe there's somebody here, right? Now here's a smart person that, oh, I guess they're over a 4.0 again. There's that. Maybe somebody's here, etc., right? You can imagine possibly something like this happening. Could you have outliers here? Could you have somebody that just puts hardly any time in whatsoever and still has a high GPA? Of course. But I think the more and more students that we sampled, I think a true pattern is going to develop where the more hours you put, the stronger the relationship. So my guess, moderate to strong, positive, and linear with a fair number of outliers, those oddball cases. All right, so that's those two. We'll flip the page. I think this is the last page in the lesson, which is always exciting. Lurking variables, we've touched on this. To summarize what a lurking variable is, whenever you look at how two variables interact and you find a relationship, you have to be conscious, was there something in the background that was causing the relationship that you're seeing? Okay? That would be a lurking variable that's sort of lurking in the background. Sometimes a hidden variable stands behind a relationship, would affect both the y and the x variable, response and explanatory. So some quirky, quick examples here. Children with larger feet can read at a higher grade level. I mean, just think of the scatter plots. Down here is foot size. You measure it in inches. Here's reading level. If you grab, I mean, you're going to see something like this. Clearly a positive relationship. The bigger a child's foot is, the better they read. Does that mean that foot size is causing you to read better? Of course not. What's the lurking variable? We have a long line here to write a small answer. Of course it's age. In general, older children have bigger feet. In general, older children read better. So there's your lurking variable, lurking in the background, affecting both foot size and reading level. All right, 1 of 4, 3 to go. We get to call it a week here at Video Recording Headquarters. Example 2, students, air conditioner sales have been found to be associated with bank robberies. It's true. Ice cream sales and murders both move in the same direction, possible lurking variables. So for whatever reason, it's been documented that as the temperature rises, well, crime goes up. I don't know if people are agitated or just criminals don't like to come outside when it's cold in the winter, but you know, the temperature, outside temperature, as the temperature rises, air conditioner sales go up, ice cream sales go up. But for whatever social phenomena, whatever reason, so do murders and bank robberies. So we would never think ice cream sales are related to bank robberies. But there's a lurking variable. 2 to go. A little bit of a more tricky one here. Number 3, damage associated by house fires is highly associated with number of firefighters on the scene. Damage in dollars. So say there's a house fire, and once everything gets cleaned up, we get a bill for how much was the damage, right? For the insurance or something. If we count up the number of firefighters on the scene, we would notice a pattern. As there are more firefighters on the scene, we happen to notice that there's more damages in dollars. Lurking variable, size of the fire. Big fires have lots of firefighters. Big fires cause lots of dollars in damages, right? So the underlying size of the fire would be a lurking variable. Okay, that's 3. One more to go, then we'll be done. Bit of a longer scenario here. It says to come up with a few possible lurking variables. What I'll write down are not the only answers. A researcher studying violent behavior in elementary school children asks the children's parents how much time each child spends playing video games. So that's one variable, hours playing video games. And the teacher then gives the child a rating on level of aggressiveness. So X is hours playing video games each week. Y is the teacher's rating of the child's aggressiveness. Researchers find a moderately strong positive correlation. So let me just write down what I said here. X equals those hours of playing video games. Y is the aggressive rating. And researchers find a moderately strong positive. Oh, we'll just throw, I'm making this up. Don't think there was anything that went into this, but here. They come up with an R equals 0.68. It's moderately strong. Possible lurking variables. We've used this example for quite a long time. I've had probably 10 good answers come across. I have 2 here that I'm thinking. Number 1, hours spent playing video games reduces hours spent socializing with other children. So the lurking variable is your socialization, right? If hours spent on video games reduces hours spent with other kids. So what the heck's a lurking variable? I'm not sure how to really put it into words, but you can get the idea, right? If a young child doesn't have those socialization skills developing, working with others, and they're playing video games, violent or not even violent, well, that's going to affect certainly the hours playing video games, and it will affect your aggressiveness rating at school, right? So that's one thing that might be happening in the background. One more, a second one that's come up quite often would be parenting style. So parents of children who are apt to let the child play video games all the time might also be the type of parents that don't really teach life lessons and work with their children on developing social skills, teaching them lessons between right and wrong. So parenting style could be in the background as well, right? Parenting style would certainly affect hours playing video games. Parenting style could certainly affect an aggressiveness rating. And so in both of these cases, you could make the argument that it's not the video game playing per se, it's the other thing in the background. It's whether the child doesn't have time to play with other kids, or if there's a parenting style that's affecting it in the background. All right, I do believe that's the end of Lesson 8. Always good to check these off our list. Same for you watching them. Thanks for watching. We'll see you in class. And take care.